If we add everything up, it's just one big mess. And there's a good reason for that. The reason is that some, as I said, because some artifacts are better preserved than others, and some artifacts are easily recorded than others, we get some artifacts that are quite ubiquitous. We get bricks at every site, for example, making everything being related to everything else. So we can explore this further by thresholding it in some way. We can explore how that degree distribution is reflected in different data types. So if we do that for the alieni, for example, which we get a very similar kind of thing, so that's not very interesting. But please note that here you can see the number of sites this is based on. Obviously, if we start thresholding, our large amount of data starts to decrease significantly immediately. For architecture, we get a very similar pattern. Again, a lot of sites being related to a lot of other sites, and that's because every site has bricks. Ceramics, we get a more interesting pattern, though, a larger diversity in terms of the relationship, the number of relationships of sites. So I think this is something worth exploring. So we'll explore this in I'll have a look at the degree distribution for ceramics in the Iberian and the Republican times now. In the Iberian period, we again get the same degree distribution. Basically a dense ball of connections, a lot of sites connected to a lot of other sites. But for Republican times, we get something totally different. We get just a few sites that are very highly connected, but a lot of sites that are actually, that have far less connections. So that's a pattern that's immediately visible from this network analysis and worth exploring. It might actually tell us something. So let's explore that. This is the network we get for the ceramics in the Iberian period. We see what we would expect. We see a dense ball of connections and just very few sites in the periphery. But the ceramic networks for Republican times is totally different. We get different clusters, not being related to each other directly or not being strongly related to each other because they all share different artifact types. They all share different ceramic types. And there's only a couple of sites in the center here that are connected to multiple clusters, and they're the closest to what we can find in these networks as being hubs, because they connect different clusters of networks, possibly different communities, for example. Now, this is still a very, very dense network. This is still very, very messy. And I decided to threshold this a bit further, just leaving those relationships that are the strongest. Those relationships that are based on the most evidence. So these sites here are all related to each other by having at least 3 artifact types in common. And then we get something like this for the Iberian period, still all connected to each other, but quite different for Republican period. Again, it starts to fall apart. These sites are very strongly related to each other in terms of the ceramic distribution, but it's a totally different pattern. We could be interested in exploring whether this has some kind of like geographical logic to it, whether these sites are actually closely related, closely positioned to each other, and in fact they are not. This represents that ceramic distribution of the most prominent patterns for the Iberian times, showing that the sites are basically all over the place. And this is the same for Republican times, showing those different kind of islands, the different kind of components in different colors, and there's no real geographical logic. Maybe apart from this first component here, which are 4 sites excavated by the same archaeologists, the ceramics of which published by the same ceramic specialists within the same project. So this is kind of an issue of data provenance that's immediately visible and that we can kind of take into account in our interpretations. Now, what's the reason for this? And the reason, this is a pattern. I'm not a material specialist. I'm an archaeologist, but I'm not a specialist in Roman times in southern Spain, for example. But I could identify this pattern. This is something that jumped at me and that I thought was worth exploring. And when we looked at the individual sherds, the individual pottery sherds making up this pattern, we noticed that there's a big shift in these things. For the Iberian period, these sites are basically related to each other because they share locally produced ceramics, whilst these sites all share imported Roman ceramics, which is a big change from the Iron Age to the Roman Republican period. Now, if we assume that this could give us a hint of how sites actually related to each other, and whether if in Roman times you had a very big shift from a local production of ceramics to an imported production of ceramics, did that actually affect the ways these plates were related to each other? I mean, these are things we kind of have to interpret, obviously, but I think this is an interesting way of doing this. Now, these are the kind of things we can expect. We can explore our big data set, we can explore the individual shards, but we can also see the big patterns, and we can, material experts and experts in all of this data basically can sit together and explore whether this actually makes sense. Whether there was something like an or a system of urban connectivity, and whether we can see this. Going back on that geographical side of things, this is just the final thing I would like to introduce to you. It's another aspect of our method. We also explored the hypothesis of whether the geography plays some role, because it's kind of an obvious assumption that places that are closer to each other, or places that might be bounded by national boundaries, for example, might have had a higher probability of being related to each other. And we did not want to explore that explicitly as such, because we wanted to explore the relationship between the data in the first instance. But we decided to explore this as a geographical hypothesis, and we decided to explore this on the one hand through the road networks, for which we have good data, but also through visibility. Now, what we decided to do is run a visibility analysis for all of these 190 sites. And we did not do it just once. So what we do is we calculate, based on a topography model of this region, what kind of area could be seen from this one site standing on this one site. But we did not do this once, because obviously sometimes there could have been a tree in the way or something. Or at some days, visibility could be less than other days because of fog and these kind of things. Also, the creation of that geographical model is an interpretation as such, because it's an interpolation of survey results by archaeologists or by geographers or something, whoever created this. So there's a lot of other parameters we have to take into account, too many to actually include in a model. So what we decided to do is to run this model for every site 100 times, but with a different random error. So we basically add 5 meters or subtract a range between 5 meters from every cell within this topography model, run it 100 times. And this gives us an idea of decreasing probability, random probability, from this, the place of actually seeing, from that specific site. Now we did that for 190 sites. Initially for an area limited to 20 kilometers around the site, but then also for the entire area as such. And then we get two things, two different networks. We get the red network, which represents those sites related to each other because they are visible from each other, like one site can see another site and another site can be seen, and also with different degrees of probability. And then the green one represents the same thing, but then unlimited, so not limited to a 20-kilometer radius. Now this kind of represents, this is a network representation of our geographical hypothesis, being that sites are related to each other if they can be seen by each other. We can explore that with that increasing or decreasing probability. And then we get patterns like this if we visualize it as a network. In the Iberian times we have a network that is almost completely connected to each other apart from a couple of components here, and with areas of high visibility, of high intervisibility, a lot of sites that are very visible one from the other, with high probability as well. Now this changes dramatically over time. The network becomes less dense and starts to fall apart into different components until we get this kind of like skeletal structure in the late imperial times, far less dense and a lot of different components. Now, and these are the numbers. Now, this isn't very interesting as such, because it's really just a direct result of the sites that we decided to include in our analysis, and it's something that is more inherent to the landscape than it is inherent to Iron Age times or Roman times or imperial times. So what we want to do is compare this network, compare this kind of geographical hypothesis with our archaeological data networks to see whether this geographical structure is actually represented in our data. And we have not done that yet. So that's something, that's my work basically for coming month. But I think, I hope this is our application. This is how we use complex networks. I hope I kind of illustrated that we can explore things, because we really wanted to confront the challenge of being able to explore a lot of data together without forgetting the issues surrounding the individual shirt, the individual coin. And also, we have the hope that this will tell something, very simple aspects of how complex systems in the past behaved and how they evolved. Now, this is my application. Johannes has different applications. There's a lot of different archaeologists and historians working with this, and as I said, I hope we can work together and try to explore this potential, because it's very much a new thing in our disciplines. And I would like to thank you for your attention, and these are all the people who worked on the project with me. Thank you.